Namaste everyone. Now we will discuss the factorization of the cubic polynomial. For this we have a question. So first of all we are going to suppose the given polynomial as fx. Fx, it is a function of x because the only variable that we have in the polynomial is x. Now first of all we will observe the constant part of the polynomial, that is 16, and we first of all find out all the factors of 16, both positive and negative ones, and we will replace the value of x with one of these factors at a time, so that we'll get a functional value 0. So here in this case, if I put x equal to 1, we will get the functional value at 1 as 0. So since f1 is 0, we can use the factor theorem, according to which x minus 1 can be stated as the factor of fx. Now I'm going to use the synthetic division method, and I'm going to divide fx with the factor of fx, that is x minus 1. So by the use of synthetic division method, we will get the remainder to be 0, and it should be always true. It is because when we divide a polynomial with its factor, the remainder should always be 0. Now I may rewrite fx as x minus 1 times the quotient, and here quotient means 3x squared minus 16x plus 16. So this part actually gives the quotient, which I have written over here. And we also need to remember this one algorithm of division, that dividend is equal to divisor times quotient plus remainder. But here remainder is 0, so we can omit it. Okay, so the first factor here is x minus 1, which is linear, and we don't need to factorize it further, whereas the second term, being a quadratic polynomial, we can factorize that, and we will use the sum product rule to factorize it. So when we factorize the second factor, which is the quadratic expression, we will break it down to x minus 4 times 3x minus 4. Hence we can rewrite 3x cubed minus 19x squared plus 32 minus 16 as the product of x minus 1, x minus 4 and 3x minus 4. And this is the required solution. So in this way, a cubic polynomial can be factorized using the factor theorem and the synthetic division method.